Hello, this is Alan again on another of my built-in functions to the ECL language. That's the Enterprise Control Language. This time the second variant of denormalize. The previous video was on the first variant and I'm doing the other way of running denormalize now. So just a quick recap, denormalize takes flat data sets and merges them into one hierarchical data set. So here we have separate addresses, separate list of names, joinable by some condition, and they end up in one data set with a list of residents attached to a particular address. So this was the first format of denormalize, variant of denormalize I showed you, and and it runs singularly. Basically, each record is child record is processed in turn. Just work through. We saw this on the previous video. That's the output record with the next input record coming in. There, so that's the denormalized row by row. There's another variant which allows an entire child data set that matches the parent to be presented in one go as a data set to the denormalized right hand side. So this is dictated by the different parameter passed to the transform function. Rows right is just a way of indicating to the compiler that the transform is expected will be taking a data set rather than just a record. So the same as before, that the output and input records for the parent have to be of the same type. So there's always this conversion. Whoops, what have I done there? Sorry about that. So there's always this conversion using a project to get the parent record into a suitable format, and then the entire data, all those child records that match the parent joinable field, in this case 1, are presented at one go to the denormalized right hand side, and then the second time. So that's it's just actually processing away, and there we go with the the output record, first output record being generated, and that single record being passed as a data set to the right hand side of this denormalize. So let's see how to edit the code to ECL to produce this result. This is exactly the same ECL that we had last time. Just a quick reminder of what it did. Hopefully won't take too long. There we go, let's just look at it. There, outputs, 5 rows, lovely jubbly hierarchical data set there. So what do we have to do to convert this to use the second variant for denormalize? Well, first thing is there's no counter in. The counter has no meaning in this variant, so we have to, if we're using counter, we just have to get rid of it. Okay, so I'll just get rid of counter there. The initial project to transform it to the output format, the parent record to the output format, that remains unchanged. And now here, really, it indicates that we want a data set, we have to put this parameter group in. All the other parameters there saying the same, and the parameter, as mentioned earlier, to the right parameter to the transform now becomes rows right. Transform itself is where most of the change happens, and here instead of being presented as a record at the time, it's being presented as a data set at the time. Data set of our name, so that's now a data set. Now this of course is no longer a row being presented at the time, so this will obviously have to change. This parent's assignments is fine, but this now we have to process a whole data set rather than a record at a time. So instead of a row function, let's just project. This is one I wrote earlier just to speed things up. So I've got the input format of record type our name, but of course residence is not the input format. It's actually our name and not the ID, because the ID is being propagated as the parent record, and we know they're equal from this statement here, so we don't actually need the ID in the residence. So this is the way it's removed from the child data sets here. But it does mean that our input record, we have to transform our input record set to the output type of the child data set, and as we had before, project is a way to do that, vertical tab, but project is a great way to do it. So that's taking a data set of our name, a record of our name, then it's got to convert it to the record of our out residence, and just says self becomes equal to left. And I think that's all I have to do. So let's give that a whirl and see what that does. Oh well, I wasn't going to get it right first time, was I? 12. What's wrong with 12? Oh, I missed. Make that record structure. Let's submit that again. Oh gosh, now it's going to take ages. There we go. Oh, and that's succeeded. And looking at an ECL watch, it's better. 5 rows again. Exactly the same output as we had if we compare with the previous one, but we haven't got counter, as counter has no meaning in this context here. So really all that changed was this specifying group parameter here, adding that to the denormalize itself and changing the type of the right hand side from a write record to a data set of write records. Transform itself has to cope with a data set instead of an individual record. That's fairly trivial, and there you have it. Now don't just assume that this is going to be faster than the first variant. Don't choose which variant to use on functionality. Don't choose it on what your view is of efficiency, without actually going through timers and things like that. So you've got a whole list of timers that you can view here, so you can dig down quite deep on that. But don't make any assumptions about which of the variants is faster than the other. Some may be faster in some context, and what the other will be faster in another context. Anyway, that's all I think I have to say about denormalize, and I'll see you in the next video. Cheers, bye.